Yes, today we are going to discuss another application of solar energy, that is what a solar water heating. So it is also called as a hot water supply system. And this solar water heating have some basic elements. It have some basic elements like it needs some basic element like the flat plate collector, okay, a storage tank, circulation system, auxiliary heating system, and control system just to monitor entire this water heating system. We need a control system, and the use of this solar energy for heating water in a many respects quite similar, okay. And to use of this heating buildings also we can use, and also we can use for the home applications like bathing purpose also we can use the same solar water heater. And so this makes it potentially a better investment for energy and money. That is most important thing. It's a better investment for energy and money and effort than the solar building heating purpose. And for one thing, the demand for the hot water is relatively constant throughout the year. We already know that the requirement or the demand for the hot water we are using for bathing purpose or any other purpose, but the requirement is throughout the constant is same. Thus the collector and the other part of the solar water heater will be working harder and longer to produce the saving in the fuel, eventually must play for its higher initial cost of the system. That is the most important thing. If you use this solar water heater, we can eliminate the use of fuels. So fuels, we already know that by the combustion of fuels they produce energy. So it is a one thing, it's a costly. Second thing, it produces a pollution. So by using this solar heater we can eliminate this problem. The solar building heating systems, and in the of course for the building heating or space heating, both are same. If it is a space, means within the room also we can use for room heater or roof heating purpose or space heating purpose, or even entire building also we can use for heating purpose. Clear? And the simplest type of solar water heater what we are using, the simplest type of water heater what we are using is thermosyphon. So thermosyphon is the simplest type of water heater, okay. And this water heater or hot water supply system, it produces the hot water. Clear? It produces a hot water or solar water heating, both are same, because the water having a higher temperature absorb the heat and it's become a higher temperature. And this simple type of this water heater is called a thermosyphon, okay. And here this we can categorize in an three important type. It's a three important type of solar water heater what we are going to discuss. The first one is a natural circulation solar water heater. Natural circulation solar water heater. Second one is a natural circulation solar water heater, but it is a non-pressurized. The first one is pressurized. In the bracket I mentioned pressurized means it's having some high pressure. But second type, it's a natural circulation of water, but it is not pressurized, it is non pressurized. And the third one is a forced circulation solar water heater, okay. So these are the three types, okay, we are using for a water heating purpose or solar water heater, okay. First we go with the first one. First one, it is called as a natural circulation solar water heater. It is called a pressurized, okay. So this type of solar water heater we commonly seen in our house, okay. So most of the house are with a solar water heating system. So that solar water heating system what we are using for our house, it is mounted on the terrace. Yes, that is what we call it as a natural circulation solar water heater, that is pressurized. So here it consists of a tilted collector. You just observe, if you have a free time you just go to your terrace and you just observe, have a look on the solar water heater. So it is have a tilted collector. So the collector is a tilted. We already know that what is meant by collector, what is meant by absorber, everything we discussed. So here the collector is tilted. So the collector is placed here, okay, and so this is what the collector. So collector, okay. So this collector will collect the solar radiation, and it is having a some inclination. It is not exactly horizontal or vertical, it is having a some inclination, and this inclination is just due to because of the effective collection of the solar radiations. And this collector with a transparent cover, we already know it is made with a transparent color, and below that there is an absorber, and it is made with some metals, okay. Then below that there is a tubes, and in the tube there is a water is flowing. This is what the a system, okay. And this is highly insulated water tank, and we are using highly insulated water tank just to avoid the heat loss. You just observe in your solar heater, water heater. So there is a flat plate collector, okay. So or tube like collectors, and above that there is an a small tank, okay. It's a capacity of 100 liters or 200 liters or 300 liters, a small tank which is completely insulated. You just touch that tank. Also you can't feel it is heat or it is cold, because it is completely insulated, okay. That insulator we are using. The bottom of the tank is at least off, and the gap, the distance between, yes, you just observe the distance between this tank and the solar collector. The tank and the solar collector is of at least 1 feet or 0.3 meter. It is with 1 feet or 0.3 meters. That's why it is called a pressurized. If the gap between the collector and the tank is have some distance, then it is called pressurized, because it creates some pressure, okay. And the top of the collector and the auxiliary energy is required to circulate water through it, okay. And circulation occurs through natural convection. So circulation occurs through natural convection, means the circulation, whatever the water inside this tank, to the collectors and to the pipe which is beneath the observer plate, okay. So there is a connection, and this circulation is because of natural circulation. Then how it is natural circulation? Okay, as the water is heated, we already know that where the water is heated in this passage, okay, and through the collector absorbs the energy, okay, and get heated, and it become density decreases. Once the water get heated, its density become decreases, okay, and hence it rise and flow it into the top of the storage tank. So this is what the storage tank and pipe, everything is connected, and it is of course here that in the storage tank this whatever the water present in the pipe, okay, and beneath the collectors, it will absorbs the energy, and because of that energy water get heated and become a lightweight. The density become lightweight, and once it is become a lightweight, and slowly whatever the water become a light dense water, okay, that is what hot water, and it is slowly flowing to the top of the tank. And in this tank is not completely a hot water. It is having an, at the top there is a hot water, it's a lighter, and in the bottom it is a dense water, means it is a cold water, it is having a density is very high, so it is a denser. So in the bottom there is a dense water with a high density, and it is a cold water, and in the top of the tank there is a hot water with a low density. And once it is start moving to the top, and again this in the bottom, it will supply the cold water to the again the collector and the observer system. Again in the observer, it will absorb the energy, and it is again become an lighter, and it is again moving to the top. So in this way, most in the top of the tank there is a hot water is available, okay. And this hot water is drawn off from the top of the tank as required, and it is replaced by the cold water from the service of the system or from the bottom of the tank. As long as sunshine, the water will quietly circulate and get warmer after the sunset. So once the sun is there, okay, it will circulate the water because by heating. Once the sun set, there is no availability of the sun, so that this process will stops. And to provide, of course, once there is no this process means, yes, slowly it will start reversing, means whatever the hot water present in the tank will slowly again it will discharge, or it will lose the heat, and it will become a denser, and it is moving back. So this is a reverse process. But to avoid this reverse process, okay, we are provide means we just placed this tank above the that solar collector. Just to avoid this reverse process, we placed solar tank within 0.3 meter. If it is not placed, if it is placed equal to the solar collector or less than solar collector, again the process will start reverse. And to provide heat during the long and cloudy days, if the cloudy days is there, or if the sun is not available, or any climatical changes, then we have to go with an electrical heater. Okay, you just see in the figure, there is an auxiliary heater. There is what electrical heater. With the help of electricity, we are going to heat this tank just to supply the constant water, hot water supply, hot water distribution. Okay, and a non-freezing fluid may also used in the collector. Here we are using a non-freezing unit, because in the daytime, of course, sun is there and it will get heated. In the night time, there is no sun, so that the temperature may reduce us, and it may become, that water may become freeze, so that we use a non-freezing fluid. Okay, so or some non-freezing fluid, so that it will avoid the freezing. So this is what the typical application of natural circulation. So it is an pressurized, and this tank, of course, we can take out that hot water for our any useful purpose, and again in the another side we have to fill this hot water with the help of sump. Okay, means water supply. And for this purpose we can use a pump. So pump is used to continuously feed the water for the water tank. Clear? And this is what the insulation. Okay, tank is covered. So in your terrace, you just observe there is a flat plate collector, and nearby flat plate collector there is an insulated tank. Okay, and entire this system is connected with your 500 or 1000 liter capacity of overhead tank. Okay, it is connected with the overhead tank. From the overhead tank, there is a continuous supply. Okay, there is a continuous supply for the water for the this hot water tank, and from this tank to there is a collector. So like this, it will continuously heat and warm the water. Yes, for the next so next is natural circulation solar water heater, but it is not pressurized. So the difference between the previous one and here one is the position of the tank. Yes, you just observe this tank. So in the pressurized system, it is available to supply hot water at a location of the storage tank, and this creates a considerable stress. In the previous one, that creates a considerable stress and produces the pressure. That's why it is a pressurized. But a non-pressurized system, the supply of hot water by gravity, by the gravity only, it will supply the pressure, that water to the collector, and flow into the users lower than the tank. Yes, you just observe here, this is a tank and this is a collector. The position of a tank nearly same, but in the previous one, the position and the tank is have some distance, 0.3 meter or 1 meter, at least 1 meter, but here it is nearly same. The collectors nearly equal to the tank. So this type of system we can call it as a non-pressurized. Here there is no pressure. Here there is no pressure. And if the height of the distance cannot be accommodated, only the solution is to install a pump. We use some pump and a pressure tank. Of course, there is a tank and we use some pump. The stress within the non-pressurized systems is lower when compared to the earlier one. And this is what the typical construction. And here we are using, you just observe, here we are using a one-way check wall. In the previous one, there is a height. That height itself avoids the return of the hot water to the collector. because in the daytime only we get the solar energy and absorbs the energy, and that will heat, and that will become a light and it will move to the tank. But in the night time there is no sun, so that there is a chances of reversing the process. Just to avoid that one, we use a one-way check valve. Okay, here also we use a check valve. The check valve will avoid the reversing of process, and it will stay hot water in the tank only. That's why we are using the one-way check valve. So one-way check valve means water flowing in only one direction, it won't move in the another direction, only one way is allowed. And of course here also same thing, cold water, hot water, and hot water we can take from the tank for any other useful purpose and continuously feed the cold water. And there is an auxiliary heater in the rainy season or in the cloudy days, where we cannot able to get the sun rays, so on that time we can use this artificial heating of the tank, so that we can get the continuous hot water. And here same thing, the same figure, and concrete blocks. On that we are going to install the solar radiations, and this pipe is connected to the tank, and here bottom of the tank is connected to the again solar radiation collectors. So from this bottom we got the cold water, and the top we get the hot water. Okay, and everything it is insulated, and it is of 15 mm insulation. Insulation is very high, just to avoid the losses. Yes, come to the third one. It is called a forced circulation solar water heater. So the forced means the first two one is the collectors and the tank are either have some difference or it is equal, so that there is a natural circulation will takes place. But in the forced circulation you just observe or the check. So the circulation it includes that electric pump of course, and the tank and the collectors are placed there. The tank, whatever the tank is there, that hot water tank, it is placed below the collectors. It is placed below the collectors, so that we need some pump or some external work to supply water from tank to the solar collectors. That's why it is called forced. By force we are supply water. So clear? This of course this system is included with an electric pump, and in the return circuit between the bottom of the storage tank and the lower head of the collectors. The tank can be placed at the more convenient level, that is what the house basement, we can place it in the house basement. And this is now an active system, and the control unit permits the pump to operate only when the temperature of the water is at the bottom and the tank is below at the water of upper head. Okay, and here also we used some check valves. Just always the check valves is used to avoid the reversing of this process, and this prevents also reversing of circulation of water as a results in the night time. Okay, there is a thermal losses. And in the auxiliary heaters, of course here also same thing, we are using the auxiliary heaters where in the night time we are not able to get the solar radiations. Okay, and when there is an danger of freezing, so here there is a chances of freezing of the water may be drained from the collector. If there is a chances of water is freezing chances, we just drain out the all the water from the tank, and we can freshly fill the water tank. Okay, and freezing danger can be overcome, although some of the increasing in the cost, by using anti-freezer solution. Of course we can use, but it has become costlier. So this is what a typical forced circulation system. You just observe here, this is a tank and collector, it is always placed below that, so that for supply of continuation water we use the pump. Okay, and here also we use a one-way check valve just to avoid the reversing of process. And here we use a pump, a switch, and a tank temperature sensors. Just to these things are used to maintain the temperature within the tank. Okay, and we get the continuous hot water for any other useful purpose. So these are the three important types of water heaters. One is natural and second is also natural, but the difference is first one is non-pressurized, second one is pressurized, and third one is forced circulation solar water heater. Yes, move on to the next topic called a space heating. It's the next type of application. After water heating, we go the next type of application is called space heating. So these are all comes under the solar applications. Okay, so it is also called as solar heating of buildings or simply space, a space heating. So many different concepts have been proposed for using of solar energy in a space heating or buildings. There are primary categories that what we virtually all solar heating systems may be divided into two main categories, that is what a passive system and active system. Okay, the first one is passive system, means in which the solar radiation is collected by some elements of structure itself, okay, and admitted directly into the building through a large, okay, through a large window or duct systems or window systems. That is what passive. So here we are not using any type of mechanical devices, okay. But the second one is, it is called active systems, which generally consists of some of the mechanical devices, okay, mechanical equipments, and some like a separate solar collector we need, and we need some heated either just for the heating a water or air, then storage device, okay. After the collectors we need a storage devices, and after that a blacking backup systems just to provide the heat for continuous supply, okay. So backup systems, a storage devices, and a separate solar collectors. This is what devices we need in the active systems. But in the passive systems we don't need anything. Directly it will expose to the sun and get heated, and that will supply for the room space, okay. So these are the main two categories. Based on this we are going to discuss our solar heating of building or space heating. First one, we go with a passive systems, okay. So passive type of system, and this passive type of systems operate without, I told it operates without a blowers, without a pump, and without any mechanical devices. The air is circulated passed over a solar heated surface and through the building convection, okay. And of course it's a less dense, and when compared to the other systems it is having an less heated air or a water, okay. And the cooler air moves into the down, okay. And this is what the passive systems. But in the passive systems, and if we compare with the active systems, this passive solar thermal systems are more practical in locations where there is an ample winter sunshine, means we get an ample supply of solar radiations, and unobstructed, and unobstructed southern exposure, means we have to expose this entire system for south facing, okay. So in the south facing there is no obstruction. If there is no obstruction in the south and there is an ample winter sunshine, then it can be possible this a type of passive systems. It is more economical one because it's having a less devices. But building to be heated, an essential part of the systems is designed. The active systems on the other hand can be adapted to the most any locations, means you can use the active system for any locations. Passive systems is only restricted to an ample supply of sunshine as well as unobstructed southern faces, but this active systems can use in any locations and any type of buildings, and however this is more expensive when compared to the passive systems, but having some of advantages. Its systems can building and maintain the same temperature in the daytime as well as in the night times, and we can control the heating temperatures, okay. So that's why there are two different methods. One is passive and active systems. Okay, first one we go with an passive heating systems. So in the figure or in the slide you just observe there is an passive type of heating systems. So in the increasing number of residents using various passive systems have been built and under constructions mainly in the south facing buildings. It is only in the south facing buildings, okay. And it's more preferable for in the south, south in the northern hemisphere or north in the southern hemispheres, and arrangements to admit a solar radiations, because this arrangements will permit a more admit of the solar radiations, okay. and when the system is used for this, and sunshine is low in the winter, we know that sunshine is low in the winter and have been termed as solar houses. Okay, so this is this type of passive systems operate with a seasonal wise. In the summer we get a more, and in the winter we get a very less, because it directly based on the sun. And the what the building prefer for this type of passive systems have some properties, means we cannot go with simply for all the buildings, we cannot go with simply all the buildings, we have some restrictions, and some properties should follow for this type. Okay, so it will function, the first property of the building should be it will function as a solar collector, it will function as a solar collector, and it will collect, it will act as a, that entire building act as a solar collector, and it will collect the solar rays from the sun. Okay, second important property is the building will function as a solar storehouse, it will function as a solar storehouse, it must store the heat. Okay, it will store the heat, that building should store the heat, and for the cool times when the sun is not shining, means it will supply the heat when there is a cool time where the sun is not available, it's like a storage, so that it will increase the efficiency. And the third property is the building will function as a good heat trap, means it will act like a heat trap, so glass is like a heat trap. Okay, like this building should also act like a heat trap, it will trap the heat, it won't allow to lose the heat from convection, radiations, or any other type of losses. And for this so the wall and roof, for this type of passive systems we preferably with a wall and roof type of building we go with, this systems are generally installed. And this systems have there are 5 important type. First one is direct gain, so direct gain. Second type is a thermal storage wall. Third one is attached sun space, and fourth one is roof storage and convective loops. Okay, these are the 5 types of principles we, or type of systems where we use in the passive heating systems. The first one is direct gain, means in the systems the building have a south face wall and the large number of windows we are using, and this windows is covered with a 2 layer of glasses just to minimize the loss, heat loss. So this is a direct gain, directly from the solar enter into the room, it's a direct method. And come to the thermal storage. Okay, come to the thermal storage, a large wall like a mass, where large wall like a mass which is absorbs the solar radiation and stores the heat, and it is placed directly behind the large south facing windows. It is a south facing windows, beneath that we placed a large wall like a structure, and will absorbs the solar radiations and stores the solar radiations. And this best known example for this storage wall is a vertical trump wall. So typically what tramp wall. Okay, this made with a concrete brick, this made with a concrete brick with an 0.3 meters or more thick. Okay, we can use. And come to the next type is it is what I told, attached sun space. So in the attached sun space, okay, in the figure you just observe, it's a attached sun space. So in a sun space, it's a very enclosed space where act like a greenhouse, it will act like a greenhouse with a glass wall and the south side, that window with a glass wall, and it is in the south side. A sunshine may be attached, okay, to a thick south wall and building to be heated by sun, and went near the top and bottom of the building, and it permits circulation through the main building and heated and with a sun space. And this heat storage provide the thick wall concrete and it will avoid the heat losses, and also water containers for the other materials for space heating purpose. So this is what the structure typically, here it is a glass and here it traps the heat, and this hot air, it is have the 2 vents, through that it will enter into the room or space and it will heat, and once it is become a cool, again it will back into the same structure. Okay, again it will absorb the heat and become heat. And the fourth one is a roof storage system. Okay, Yes, you just observe it's a roof storage system, and in the roof storage system it's a passive type of systems, of course, and this trademark for this is a sky term. Okay, it's a sky term, it's a trademark where we can design for the house. It is a design for particularly for the house having an flat roof located in the a mild climates. The heat is absorbed and stored in the water about 0.2 mm depth and contained in the plastic bags held in the a back-ended steel box on the house of the roof. You just observe, this is a figure, this is a figure for the roof storage. Here this is a main roof. On the main roof there is a chamber where the water is stored. Okay, a stagnated air space we provided, and the plastic water bags, these are the plastic water bags, in that water is filled, and this is exposed movable panel where the sun is available. You just open this panel, and so that it will absorb the heat and it will trap the heat. And this is what the metal container. In the metal container there is a plastic bag filled with the water, okay, and directly exposed to the sun, and it will absorb the heat and it will trap the heat. Okay, and between that there is a space available, and in the space available the water is continuously flowing, and that water will gain the heat from that water bags, and that air will continuously supply to the main space or building for heating purpose. And the last type of is a convective loop. So in the most passive solar space heating systems, the heated air is circulated by convection. The second figure, this is what the convective loop. And the most passive solar systems is heated in this type of systems, and heat is circulated by convection. But in the term convective loop is applied to the system that it's a resemble with a thermospin or hot water schematic, or it is also like a flat plate collector. It's similar like a flat plate collector. So it includes a conventional flat plate. Of course, you just see it's a flat plate collector, and at the level below that of main structure, this is a main structure of building where we have to heat the space, and below that there is a flat plate collectors. Now there is a main structure and a bed of a rock, and nearby that there is a thermal storage, and this thermal storage is completely made with a bed of rock which may be located beneath the sun space provided the thermal storage. And the normal operation of air passage towards through this collector is heated and enters the building through the floor vents, and the cool and dense air leaving the building return to the same flat plate collectors and reheated purpose. If more than solar heater is available than required for a space heating, and the floor vent may be partly closed, and this heated air then flows through the and the deposits heat is stored in the bed, means where the air circulation is there. Once the room air is reaches required heat, then we have to stop this process. Okay, stop the wall, and next this collector heat is directly into the thermal storage, where this thermal storage is made with a bed of rocks. Here it will stores. Okay, and where the temperature is less, again it will wall is open, and again it will heat. So this is what a concept of it's, that's why it is called as a loop, a convective loop passive solar heating. Clear? So these are the main important types of so passive type of solar heaters.